All right, sorting algorithms. Today we're going to be talking about two specific algorithms, sorting and insertion sort. We are not going to be going over merge sort. Merge sort is going to be a much more complicated divide and conquer algorithm. So we're going to go ahead and leave that one for a different lesson. Now, we've talked about sorting algorithms before, or at least we've kind of referenced sorting algorithms before, and we know why it's important to have something like a sorted data structure. So a perfect example of this is we've done a divide and conquer algorithm before where we were talking about a binary search. A binary search works great and it's able to return a fantastic result in a good time complexity, but it's only able to do that if the list that we are working with is already sorted. Now, if that list is not sorted, we might want to utilize a sorting algorithm to sort it and then feed it into our binary search. So with that said, today we're going to talk about bubble sort and insertion sort. And we're going to start off with bubble sort and seeing how it works in sorting this small snippet here of data and switching our numbers all the way until we have a good list of 1 through 4. So here is our input, and I'm just going to go ahead and move that down here, turn it green, so that we know that that is going to be our desired output. And let me just do a little switcheroo of numbers here. And there you go. So we have our desired output, and now we just have to figure out how we're going to get there with our sorting algorithm. So let's start making this function. We have something called bubble sort that will take in an array, or let's just say a list, and we can reference this as a list, and it will return a list. For now, we're just going to do pass. I'm going to come up here and say that what it's going to return is a list. Great. So now I know what information I'm working with, and I can go into constructing this algorithm. Now, the ability of bubble sort, or the uniqueness about bubble sort, is that every time a bubble is analyzed and it gets popped, then the algorithm restarts all over again. So let's go into how we do that. All right. The first thing that I want to analyze is the length of array. So I'm just going to do length here. And I'm going to say, hey, my length is equal to my len of list. And now that I have the length, I can say for I, let's do idx so that we know that that is representing an index in range of n, or excuse me, length. And from there, what I'm going to do is I'm going to iterate through for jdx, because this is supposed to represent a separate index, in range of 0 and length minus idx minus 1. We're going to cover that here shortly. We'll break it down step by step. Let's just actually do this. Let's do right limit. And we'll take this out here. Put it up on top and look at the right limit. All right. Well, now that we have that, let's go ahead and take a look at a couple of print statements so that we can see how this is working. I just want to see what IDX is doing, how that's affecting JDX, and what my right limit is. So let's go ahead and print IDX, JDX, and my right limit. And let's run this algorithm. Oh, I probably have to call the function. All right, so we're calling bubble sort, and we're going to pass in the data. Let's execute main py. Okay, so here's the execution of our code. The first number that we see here on the left-hand side is 0. That is IDX. So IDX is equating to 0. JDX is then equating to 0 as well. So if we do for JDX in range, here we can see this is 0. And my right limit is the length, which we know the length of this list is 4, minus 0, because IDX is currently 0 minus 1, which gives us 3. We go through it a second time here. We still have 0. We can still see that our right limit is 3. And now we have JDX at 1. We go through it a third time. We have 0, 2, and 3. All right. Now remember, this is exclusive. So that means that I am currently only iterating from index 0, 1, and 2. And I am not looking at index 3. All right, that's my right limit, index 3. I am not looking at it. All right, on the next iteration, I am looking at index 0, or excuse me, at index 1. Let me choose a different color here. You can see that JDX is at index 0 still. So we're comparing 0 and 3. And then we are not going to be analyzing index 2. All right, so now both of these aren't being touched, whereas before only one wasn't being touched. All right. And then finally, we move to our last iteration where we start at index 2. Yeah, let's do this one. Where we start at index 2. You can see that the very first index over there is index 1. And then our right limit is here. So we never touch this at all. So we do a little bit of bouncing back and forth here, where we're making sure that we are essentially just iterating through the algorithm and trying to do our swaps in the most efficient way. And we're going to see why these swaps make sense here shortly once we actually start moving or conducting some bubbles. So now I'm going to take all of these chicken scratch drawings and move them up above so that they don't get in our way. And let's go into actually moving our function of how we would iterate through this information. I'm going to leave our, actually, I'm going to take this print statement off because I'm sure it's going to create too much noise here shortly. And now I want us to actually go into formulating our data, right? So all I'm going to do is I'm going to check, hey, if my current list at index JDX is greater than my list at JDX plus 1, then I just want to swap those two, right? And the way I could do that is I could have a maybe temporary. So let's do temporary is equal to list JDX plus 1, list JDX plus 1 is now equal to list JDX. And I can say list JDX is equal to temporary. All right, so let's break that down. What are we doing here? We're going to grab two bubbles here, and we're going to check, hey, is this current bubble greater than the one to the right? And it goes, yes, it is. Okay, well, because it is greater than it, I want to save one of them into a variable. So I'm essentially creating a copy that I am saving to temporary. That's attaching these two, right? The list still exists like this. Next, I'm going to say, hey, the list at the index of JDX plus 1, I want that to be equal to the first index. So it switches and puts 4. Well, now because I switched these two, this 3 that belonged to the list no longer exists. Right? Its place in memory is no longer there. right? The list has no number 3 anymore. The list now has 2 copies of the number 4. But because I saved my number 3 in a temporary variable, or temporary, because apparently I can't spell. Let me change that. There you go. Well, now I can reassign the first JDX, so this number 4, to the number 3, which is our temporary. And that's how I'm achieving the swap of those 2 bubbles. Does anyone have any questions over this swap here?
No, it just took me a minute to wrap my head around. I think I got it. Visualization helps.
All right, James?
Um, it makes sense to me because you can't just swap 2 positions. You have to make a third spot to like rotate them through almost. Is that like the right way to think of it? Is there no way to do like a direct swap in like code in Python code, I guess?
That's a great question. So this is the example that you just gave where, hey, we want to rotate them, but essentially in memory space, there's no way for me to rotate them without them overriding one and the other, right? So because there's no way for me to do that, I need to create a third placeholder so that I can have them rotate, right? Well, there is a way in Python where instead of doing this, if we want to shorthand it, what we can do is just say, hey, I want list at index JDX and list at index JDX plus 1 to be equal to list at JDX plus 1 and list at JDX. And by doing this, I'm just doing a direct swap between them. All right, so now instead of going through the whole temporary process and deleting code and putting things in one another, it just simply takes 4 and 3. And I say, hey, I want you to switch both of these places. So it just puts 4 up there and 3 back in the list. Did that answer your question?
Yeah, definitely. Do you recommend one over the other for efficiency or memory, etc.?
So memory wise, this is always going to be more efficient. Anything that doesn't create more variables will always be more efficient memory wise. As far as recommendation, it's user preference. I think it's important to know the people in your team and who you're working with, because if there's someone in the team that you are aware of that is likely not going to understand this syntax, either leave a comment explaining what the syntax is doing or go with the longer version. It's not going to be so memory of cost that it's going to shut down your application.
Awesome. Thank you.
Of course. Sam?
So line 13, that's called like a tuple something, right? I forget what that is called.
I unfortunately don't know the terminology
Okay.
functionality, but I know that this is a Python function.
Gotcha. I think I read it somewhere, but I was just wondering if I can like go back and see what exactly that does too.
Yeah, I'll have to look it up and get back to you with the actual terminology name. All right, and I think we had one last question from someone.
No, that was my same question. I've read it before too, and I just can't remember what it's called.
Got it. All right, awesome. So now we were able to complete our swap. Now let's see what it looks like, right? Let's say after this if statement, I'm going to print a couple of different things here. And I'm going to actually format this string here just so that I could actually visualize it and see it after every single iteration. So inside of this string, I want to see the current list. And this is just going to include our handy dandy list. I want to see the index and value. So let's say index and value. Excuse me. Yeah, let's do left cell. So the left cell will be LST at JDX. And I want to see the right cell. And the right cell will be LST at JDX plus 1. I'm actually going to take the same exact print statement. Oh, I don't know if I want to do it so many times. Just going to put it here. And instead of printing it here, I'm just going to have it print swap. To let us know that a swap did happen. All right. All right, so now once this function is completed, I'm going to have it return the list, since it should do what we want it to do. Now let's run this through the terminal. Let's take a look at our terminal information here. So it's running the first time. We can see that it has 4, 3, 2, 1. 4 and 3 were analyzed. So I brought down 4 and 3. And because it brought down 4 and 3, it created a swap. And we can see the swap being triggered down below. All right, so 4 and 3 were swapped. And let's do this number. These two are being analyzed. All right, so 4 and 3 are being analyzed. And they also get swapped. All right, so now we go into our next iteration. In the next iteration, we have 3, 4, 2, and 1. The left cell is the number 4, and the right cell is the number 2. So now we can look at the next portion. This 3 is not being analyzed. The 4 is, and so is the 2. And we can see that there was a swap again. All right, so we come over, we copy and paste, and here comes 4 and 2. All right, so 2 and 4 were swapped, and now we should have 3, 2, and 4, and 1. That's what we see here. So 3, 2, 4, and 1. Now the cells that are being analyzed are 4 and 1. Let me move that down here. All right, 2 is not being touched this time. We're just analyzing 4 and 1. We can see that a swap was triggered. So in our next line of code, we have 4 and 1. All right, so we just watched how the number 4 essentially iterated from the left-hand corner, from the most left-hand corner, all the way to the right-hand corner. Notice that it didn't move on to the other swaps in between them, right? Like it didn't move and swap 3 and 2 or 2 and 1. It continuously moved the number 4 all the way until the number 4 made it to the right-hand side. Well, once the number 4 makes it to the right-hand side and we have 3, 2, 1, and 4, you can see that the next two cells that get analyzed are 3 and 2. So now it starts all the way again from the left-hand corner. Brings down 3 and 2. These two cells are now being analyzed and a swap is triggered. Go ahead, Juan.
No, I've known about bubble sort, but I just noticed this now actually seeing it visually. So every time that the list is recreated, the very first for loop starts again at the very first index, or index 0 again.
Yes, it does. That's right.
Gotcha. Thank you.
Awesome. Of course. All right. So now 2 and 3 get swapped. It goes through analyzing this code again. The next two cells that get selected are 3 and 1. I messed that up. And we see that a swap is triggered between those two. All right, so 3 comes over, 1 comes around. All right. And now we have 2, 1, 3, and 4. Well, notice that for 2, 1, 3, and 4, it starts from the index 0 again. And that's why this whole portion of this right limit of length minus IDX minus 1 is important. That's what's stopping it from evaluating 3 and 4. All right. Okay, so we come down to the next one. And in the next iteration, it's going to simply identify that 1 and 2 are going to be our last cells to inspect. And it triggers a swap. And then finally, we get a return statement of our list here with our 1, 2, 3, and 4. All right. That was a pretty good amount of drawing there. Let's open it up for questions. Let's hear it, James.
A question about what Juan was just asking about. The first for loop, the IDX stays at 0 the entire time. Can you walk through how or why it's doing that?
That's a great question. So IDX doesn't stay at 0 the whole time. The reason why every time we start a new iteration, we start from index 0 is because of this, right? We do have IDX available, but the only reason why we need IDX is so we could make sure we're not repeating the ending numbers. What makes sure that we always start from 0 is the fact that in this for loop, we have from range 0 to the right limit. So this 0 on line 7 is what ensures that we always start from the left-hand side.
Perfect. Got it. Thank you.
Of course. All right. Okay, great. So that's going to get us the majority of our way there. There's definitely a problem with this algorithm as far as efficiency goes, right? We have 2 nested for loops inside of one another. So we're looking at, I believe it's n squared at the very minimum here, right? Which is not necessarily something that we want, but it is a working algorithm. It does what we need it to do. It is very efficient as far as memory goes, right? I do not need this variable here, and I definitely do not need, I guess I do need the length variable. That way I don't have to do the length function twice. So I could get rid of this right limit variable, and we could swap our places utilizing this functionality here on line 18, instead of bringing in a third cell for a temporary holder. Now, as far as making it a bit more efficient, if we had a continuation of numbers here, such as, hey, 5, 6, 7, and 8, and we wanted to keep a counter. Let's say counter. Let's do plus equals 1. And for every time we iterate, I just want to, oh, hello. For every time we iterate, I just want to increase that counter by 1. Right before my return statement, I want to print my counter.
Wouldn't you want your counter to be 0?
Yes, I would. Thank you. And let's actually remove this portion here so that we can see it the first time. All right, I run it through. We can see that it iterates 6 times. There was 6 different times that it was able to find a pair to swap and go through this entire function, all right? Well, what happens when we increase to, let's say, 5, 6, 7, and 8. Well, when I run it, now we're up to 28 times, right? So before, when we had 4 numbers, we saw the number 16 coming up. Where did you go? Where did you go? All right. It might be faster if I just do this. So when we only have 4 numbers, we see it at 16. When we have 8 numbers, we see it at 28, right? So 4 times 4, that gives me 16. I have 8 numbers to the power of 4. That shouldn't give me 28. So maybe I have something wrong here in my math, but it's giving us a pretty good exponential example of how things are being increased, right? Well, maybe there's a way that I could have it stop. Once it realizes, hey, we iterated through all of this, but there isn't any swap, or I iterated through the entire list and there isn't a swap, maybe there's a way that I could implement how to kill the function early. Well, we do that by adding a stopper. So we can say, hey, swapped is equal to false. And if it goes through the entire, if at any point it does swap, we want to change that to true. So we can say swapped is equal to true. So if it reaches all the way across and it does not trigger a swap for us, what we can do is say, hey, nope, right here. If not swapped, so if there wasn't a swap, then break the loop. And now when we run it, we only get 22 iterations instead of 28. One?
No, I wanted to see if we can try the list in descending order. Like if we started with 8 at the beginning, all the way to 1 at the end. I think that might give you your 64, if I remember correctly.
You're probably not wrong. Let me add that in there. 8, 7, 6, 5. Not 54. And let me take off this portion.
Hmm.
8, 7, 6, 5, 4, 3, 2, 1. No, it looks like it still gives me 28.
Do you still have the if true
You
break?
got you got the true statement still in there. It's not like how you had it originally before.
Got it. So you're
Yeah.
saying killer? All right, let me take off the killer. Yeah, still returns 28.
That's trippy. All right. Thank you.
Absolutely. All right. So let's delete that and all right, there you go. But now by adding that, right now we have 28, but by adding the killer, we were able to save ourselves 6 different iterations that we didn't need to make because there wasn't a swap that was triggered. All right. Awesome. So that's just another way to make it a little bit more efficient. This is bubble sort. If we were to remove all of our print statements and everything that we have here, you'll see that it's probably no more than 10 to 12 lines of code. All right. It's just because we have all the extra print statements and some a variable for clarity that made it a little bit wider than it needed to be. But that is bubble sort, everyone. Does anyone have any questions regarding bubble sort? I don't see anything in Yankee questions, and I also don't see anything on the Zoom chat. So let's go ahead and push forward into our other function here of insertion sort. So I'm just going to actually make a separate file just to make sure that all of our nodes stay nice and separated. I'm going to go ahead and add this insertion function. that is going to accept a list of numbers. And it's going to return a list of numbers. And for now, I'm going to have to pass. All right. Let's take in our data attribute back. All right, so there's our data. We have 4, 3, 2, 1, and we want to actually reorganize this so that it's actually being set back to 1 through 5. Well, let's work through this. Insertion sort works quite a bit differently than bubble sort. And the way it does that is it almost works backwards. So let's go into drawing our array here, and we'll talk about how that process works. Okay, there you go. We have our 4, 3, 2, 1. And we're going to start the algorithm almost exactly the same. We're going to say, hey, for index in range of 1 and length of the list. All right, so notice that difference there. We are starting at index 1. So we're saying, hey, index 1 will be my starting point. And I want to see everything after index 1. So we're going from index 1 to index 3. All right. Now, inside of that index, I'm just simply going to select an item. And that item is going to be equal to my list at the current index that I'm on. So the item that I'm selecting right now is the number 3. All right, so the number 3 was selected. It's the chosen one. All right, so there's the number 3. We have our item. Now I'm going to make a separate index called JDX. And this index will be represented by IDX minus 1. So index was here, this gold. Well, now JDX will likely be this number 4. And we'll go into how that works here shortly. So I have IDX and I have JDX to make my comparisons. And now I can make a while loop. So I'm going to say, hey, while J is greater than or equal to 0, and my current item is less than my list at index JDX, then I want to do some information. So let me pass there. And in this case, we want JDX. All right, so we're going to say, hey, if JDX is greater than or equal to 0, and the item is less than the number next to me. So currently, we're taking item, which is the number 3, and we're saying, is item less than the number 4? Well, it is, right? That is true. I need to swap my information, or I need to figure out a way that I'm going to swap these two numbers. Well, we could do that as such. I can call the list at JDX plus 1. And you may be wondering, why are we utilizing JDX plus 1 and why not just utilize IDX? We're going to go into that shortly. And we're going to make that equal to the list at JDX. All right, so let's take a look here. So we're saying while JDX greater than or equal to 0 and item, which is the list at IDX, this is our item, and list at JDX. All right, so while the number 3 is less than the number 4. If the number 3 is less than the number 4, I am going to assign position of 1 to be equal to LST, JDX. So as of right now, the number 4 is now inside of my list 2 times. And the number 3 is no longer inside of the list. It is under a variable named item. All right, kind of like how we did with the main, excuse me, kind of how we did with bubble sort, where we had a temporary variable. That's almost exactly what we're doing here. All right, so we switched those 2 arguments, and then we're just going to go through the same iteration. Well, now when we go through it again, JDX is no longer greater than or equal to 0, because we need to decrement JDX by 1, so that we can ensure that we're moving to the left-hand side of the list. All right, I want to continuously look backwards. So I go and try to move my JDX here, and it evaluates to -1. So because it evaluates to -1, my for loop is no longer being met. And once my for loop isn't met, then I just simply want to address that JDX, or excuse me, list at JDX plus 1 is equal to item. And let's draw this out. All right, we have our whole list. We've established that we are starting at the number 1. All right, so now we have a variable named item, which does not exist within the list. And it is set to the number 3. All right, then we move into our while loop. In my while loop, I am simply grabbing the number 4 and the number 3. So both of these have been selected for comparison. Now I'm going to say, hey, is 1 or JDX, which currently JDX is set to the value of 0. That's important to have. So I'm going to put JDX is equal to the value of 0. So because it is equal to the value of 0, I'm going to 1, evaluate this to true. And then I'm going to ask, is item, which we know it's the number 3, less than JDX? Right? JDX is the number 4. Well, it's true, right? The current index of JDX is less than the index, or the current value at the index of JDX is less than the value of item. So because of that, we're going to assign JDX plus 1. So when we do JDX plus 1, it turns into 1. And we are going to set the list to the current value at JDX. So what we're doing here is we're simply just making 2 number 4s inside of the list. That's what our list looks like right now, all right? Okay, well now, we're going to subtract from JDX, -1. Okay, awesome. So now JDX, because the value of it was 0, is now equals to -1. So because the value of it is 0, it kills our function. JDX is no longer greater than or equal to 0. And then we grab JDX, which is -1. We add 1, which is 0. And we assign it to the value of item. So now we have JDX plus 1, which is equal to 0. So index 0 now is assigned to the value of item. Right? And that's how we were able to achieve that swap there. Does anyone have any questions over that very first swap? Go ahead, Gary.
Do you think we can get where would I put a print statement if I wanted to see it?
Yeah, it's a great question. Let's see. Probably in here. Let me go ahead and do print. And let's do an F string. And let's do something like all right, let's do item, which is going to be set to item. Let's do JDX. And what I want to see for JDX is both. Oh, let's do JDX and then let's do the value. So value of JDX, which is just the list index JDX. And I think that would be it. So now if I were to run this, oh, didn't call the function. That might be important. All right. I'm going to scroll all the way to the top. Oh, I didn't print the list. All right, so we start all the way to the top. Here we see that the item is the number 3. The current value of JDX is equal to 0. The value for JDX is 4. So there we get 4 and 3. Well, 4 and 3, that's the list that we're currently working with. A swap happens. Now we have 3 and 4 in the next iteration. The item that we're working with is 2, right? Because we're moving to the right. JDX is equal to the value of 1. So here is 1, which is our 4. We have 4 and 2, so we triggers a swap. We are still within 2. The only thing, we're still stuck inside of this while loop now. All right, we're still working with 2. We can see how we have 4 and 4 now. That's how we see the copy, but the item is still number 2. And we see the value of 3. So now we move on to the next iteration because it evaluated that 2, 3, and 4 was a correct swap, right? So it swaps the number of 3. All right, while loop gets killed. And then this list JDX plus 1 equals item is what sets number 2 or the item at the beginning of our list. And then it goes through it again with number 1. Does a swap. So 4 and 4. Then we should see 3 and 3. And then finally we get 1, 2, 3, and 4 as our final return statement. Did that answer your question there, Gary? Or did that demonstrate what you wanted?
I did. I appreciate it. Thank you.
Of course. All right, and let's actually make sure that we kill our function correctly by returning list. And then we could just do print here. There you go. We've got 1, 2, 3, and 4. Right? It's not actually doing a swap in within the list itself. It's just holding a copy of it in item until it identifies the correct place to fall into. So it's going to either identify that slot by running out of spaces, meaning that it's the smallest number. It's no longer equal to 0, so we know that it has to be index 0, or by finding one of these indexes where item is actually greater than the current location that we're evaluating to. All right, let's take a look at a different example or a different set of data. This one might be a little bit more dynamic to see what's going on. So in this example, we have 3, 5, 1, and 4. And let's run it in our terminal. Let me close this up a little bit. So at item, we have 1. So here is 1. At JDX, we also have 1. And the value of 1 is 5. All right, so that's the first time our while loop gets triggered. Our while loop doesn't get triggered in the first iteration because item is not less than the one next to it. All right, so that's the reason why we didn't get that print statement, because that while loop wasn't triggered. But it does get triggered once it makes it all the way to the number 1. We get the copy of 5 and 5. And then after that, we get 1, 3, and 5. Then we see the number 4, because none of these 3 places triggered our while loop to evaluate to true until we get to the number 4. Once we get to the number 4, our while loop gets triggered, and we can see that it creates the copy and returns 1, 3, 4, and 5. All right, so this is way more efficient than our bubble sort, and it's definitely going to be a good sorting algorithm to memorize or keep in your back pocket as a tool. Don't necessarily memorize it unless you're really interested in algorithms and you want to impress somebody. I'm sure that if you step into an interview and they ask you, hey, what is it that we should do here? And you bring up, hey, I really want to utilize the insertion sort algorithm. I can't remember it off the top of my head. Do you mind pair programming with me to build this together? They would be more than happy to work with you in building the sorting algorithm, but please get familiarized with it. All right, does anyone have any questions regarding insertion sort or bubble sort? Demi, I know you were speaking earlier, but your mic was muted. Was your answer, did you get your answer?
So what I was saying, or what I was gonna say, which it helped with the print statement, was when does it like start if the data was changed, but then you change the data, and then it would stop again. And I'm referring to the while loop because it wouldn't equal 0, so then it would like skip it. That makes sense.
Right. So once it doesn't equal 0, it skips it, and then this is how we get it set to the correct item down below. Once it
Correct.
out of this while loop.
Yeah, yeah. So that print statement helped. Appreciate it.
Awesome. One.
So both of these sorting algorithms are mainly for things like of numerical value, sorting things numerically. Like, for example, an set of IDs in a database or date of birth, stuff like that.
Yeah, that's a great question. So when it comes to greater than or equal to, you could actually evaluate that with alphabetical characters as well. I'm pretty sure it's greater than B. Go ahead and run that. So that comes to false. And we could also see if print that Z is greater than A, and that should evaluate to true. So you could do it with alphabetical numbers as well. Or excuse me, with alphabet like strings, that would also work. It's not only just for numerical. I think anything that's alphabetic or numeric, you can apply these to. If you're working with a list that has nested data structures, you may be looking into doing some extra lambda functions to really apply this correctly. All right, any other questions? Okay, awesome. It doesn't seem like there are any other questions, so let me go ahead and stop our recording here.